All right, 6.5, integration by substitution, part 2. Here's a pretty basic rule up top here. This is a rule for when it's a definite integral instead of an indefinite integral. So this should look familiar from last video, right? If we're using use substitution, same story here. Whenever we integrate it, you're going to plug in your upper limit minus your lower limit, just like we did when we did definite integrals before. So we're kind of combining two things. We're combining what we did in the first part of this section, where we would do our lovely use substitution, with finding a definite integral, where we simply plug in at the very end. So we got a first example. Oops, didn't mean to move that around. Let's fix that. Better. Okay. So let's make u equal to 1 minus x squared and du equal to negative 2 dx, right? So we need to get x dx alone, because this is where we are at, right here and right here. So divide by negative 2, get du over negative 2 equals x dx. So we plug that in. So you're going to get the integral from 0 to 1 of the square root of u du over negative 2. Integrate, remember, that's like saying it's the 1/2 power. So we're going to get to 3 halves over 3 halves, plus, we don't have a plus c because it's a definite integral. And that's going to be equal to 1 minus x squared to the power of 3 halves. I flip what's in the denominator, make a multiplication, so 2 over 3 times the quantity 1 minus x squared to the power of 3 halves. Though I forgot the times negative 1 over 2. Where did I get negative 1 over 2 from? Right here, because we're dividing by negative 2. So that's going to get us negative 1/3. So we're evaluating negative 1/3, 1 minus x squared to the 3 halves, from what? 0 to 1. We plug 1 in. The whole thing goes 0, because 1 minus 1 is 0. So 0. We put 0 in. 1 to any power is 1, and then 1 times negative 1/3 is negative 1/3. Which is going to get you 1/3 as your answer. All right, new definite integral. From 0 to 2 of x times the third root of 4 plus x squared. So let's set u equal to 4 plus x squared. Du equal to 2x dx. So, once again, get x dx alone. Should have put it there in the integral, my bad. And then we're going to get du over 2 equals x dx. So once again, substitute the same thing. 0 to 2 of the third root of u times du over 2. I can move that 1/2 up front. And remember that the third root is like saying 1/3 power. So, I don't need it divided by 2 because I already took care of that. So, let's integrate. That's going to get us u to the 4/3 over 4 over 3 times 1/2. And then we simplify it. I'm going to get 3 over 8. Substitute in u. 4 plus x squared to the power of 4/3. We're evaluating this from 0 to 2. So 2, what does 2 get us? 2 squared is 4. 4 plus 4 is 8. 8 to the 4/3 will get us 16. And then 16 times 3 over 8 will get us 6. So 6 is our first value. When we evaluate it, put 0 in. 0, we get 0 plus 4 is 4. And this actually comes out to be a decimal. It's going to be like 2.38. That's whenever you plug in 0 into x. You put 4 to the 4/3 power times 3/8. This is what it'll come out for you, okay? So your answer is approximately 3.62. All right, we'll do one more, and then we'll move on to the next thing. So u is clearly going to be x plus 1, and du will be equal to 1 dx. Do we see a 1 dx? Yes, that's all we need. A little easier in that sense, right? So we get to the u sub part. Remember, when we dividing by the square root of something, it's like saying to the negative 1/2 power. So it's like saying u to the negative 1/2 power, du. That's how we're integrating. We add 1, which makes it negative 1/2 plus 1 is 1/2, divide by 1/2, and we're evaluating this from 0 to 1. Now, I want to substitute in my u, and we're going to get x plus 1 to the 1/2, or the square root of x plus 1, depending on how you want to write it. I flipped the fraction, made it multiplication, so it's going to be 2 over 1, from 0 to 1. Plug in 1. We're going to 2 square root of 2 when we plug in 1. When we plug in 0, you're going to get square root of 1 is 1. 1 times 2 is 2. So your solution is this. All right, so we're going to integrate even and odd functions, and some of you might have forgotten what an even and odd function is. So even function is when we substitute in negative x everywhere we get an x, and we simplify it, we get the same thing as what f of x is, as opposed to an odd function where we put negative x everywhere we see an x, and we get all the signs flipped for each term. Okay? If you remember, an even function reflects over the y-axis, and an odd function reflects over the origin. With integration of these types of functions, it's meant to kind of help us in certain instances. So let's write down the rules. So here are your rules for integration of even and odd functions. If even, then negative a to a of f of x dx is equal to 2 times 0 to a of f of x dx. So that should help you out whenever you're solving an integration problem. Why does this work? Well, remember, as I said, even functions reflect over the y-axis. So if I'm going to do a quick drawing of an even function. So if it looks like that, it reflects over the y. Really, like, the integration of this is just going to double from what's over there, depending on what the endpoints are. As long as these are the same but just flipped, you can just do 2 times whatever 0 to a is. Odd. If odd, then negative a to a of fx dx is equal to 0. Why does that work? Remember, it reflects over the origin, right? So if it flips, you're going to get the negative and the positive added together, right? Which is going to just end up being 0. All right. Is this an even or odd function? Well, if we put negative x into this function, you get the same function because negative x squared is just x squared. So, yay us. We can apply the rule. So I'm going to change this from 0 to 3 times 2 of 9 minus x squared dx. We integrate it. And it's going to get us 9x minus 1/3 x cubed. We put 3 in. It's going to get us 27 minus 3 cubed is 27. Times 1/3 is 9. Then minus 0, right? Because we put 0 and you get 0. So you're going to get 2 times 18, which is going to get us 36 for a solution. I appreciate you watching, and we'll see you in class.